Other properties that are important to discuss across a period are physical appearance. Sodium, magnesium, and aluminium have metallic lustre and are shiny. For sodium, they are shiny when freshly cut. Magnesium are shiny when polished. Aluminium is also shiny when polished. Silicon is in group 4 and it is usually categorized as a metalloid. A metalloid means a semi-metal. This is because it lies in the border between non-metals that are on this side and the metals that are on this side. So it is a semi-metal. It's sort of a transition. It contains both metallic characteristics and non-metallic characteristics. So for silicon, it is also shiny and it looks like more like a metal. Phosphorus has two colors. We have white phosphorus and red phosphorus. Sulfur is yellow. Chlorine, as we have discussed, is green yellow. And argon is a colorless gas. The melting and boiling points. When talking about melting and boiling points, it is important to divide the period 3 elements into 3 categories: into the metals, the metalloid, and the non-metals. As for the metals, the melting and boiling points increase from left to right because there is an increase in the number of delocalized electrons that increases the strength of metallic bonds. As for the metalloid, which is silicon, it has very high melting and boiling points due to the uniformity of its covalent structure. All the atoms in the structure of silicon are held together by strong covalent bonds. Hence, it has a high melting and boiling point because they require a lot of energy to break. As for the nonmetals, which are here, they contain molecular structures. So as for phosphorus, it exists in molecular form. Same for sulfur, chlorine, and argon. However, argon is special. It does not exist as a molecule, but it exists as a monoatomic gas. The molecules are held together by weak interatomic forces known as van der Waals forces. Since they are held together by these weak forces, the melting and boiling points are very low. Chlorine exists as a gas at room temperature. Argon exists as a gas. Phosphorus and sulfur exist as solids, but they have low melting and boiling points. The next property that we're going to discuss is valency. As you can remember, group 1 elements such as sodium have a valency of 1 because they have 1 electron in the outermost energy level and usually react by losing 1 electron. Group 2 elements have 2 electrons in the outermost energy level and therefore have a valency of 2. Aluminium has a valency of 3. Silicon has a valency of 4. Phosphorus has a valency of 3. Why? Because it has 5 electrons in the outermost energy level, and for it to gain a stable configuration, it needs to gain 3 electrons. Sulfur has a valency of 2. Chlorine has a valency of 1. Argon, on the other hand, has a valency of 0. When you talk about electrical conductivity, again, we need to divide the members into 3. The non-metals, the metals, and the metalloid. Now, all metals conduct electricity. They are good conductors of electricity because they have delocalized electrons. As for the nonmetals, they are non-conductors of electricity because they lack delocalized electrons. The metalloid can conduct electricity, but not as well as the metals, and therefore it is known as a semiconductor.